the Industrial Revolution, we've benefited a great deal from access to energy, but the fuels we use definitely have some side effects.
Whenever fossil fuels are burned, carbon dioxide is released into the atmosphere.
We burn a lot of coal to generate electricity, and probably will continue to do so for several decades.
With this in mind, scientists are currently working on 3 different ways to help control CO2 emissions.
Chemical scrubbers are currently the best way to reduce CO2 emissions from fossil-fueled power plants. Here's how it works.
Basically, a chemical solvent is used to capture CO2 from the gases emitted during the burning process and turn it into a more manageable liquid.
This prevents CO2 from being released into the atmosphere and makes transportation to storage locations easier.
Storage is the second area of research. Once the CO2 is captured and contained, it can be moved through a pipeline into storage areas located at least a half-mile below the Earth's surface. The catch here is that we need a lot of expensive pipeline from power plants to underground storage areas.
Both of these options are still being researched, but they have disadvantages for a real-world application.
Researchers at the University of Kentucky are exploring many areas of carbon capture.
If you wanted to do a traditional chemical scrubbing to remove carbon dioxide emissions, to do that, you would immediately put a 30% parasitic load on the power plant. That means that burning the same amount of coal, you would generate 30% less power.
An exciting new area of carbon capture is using CO2 to grow fuel. Algae represents the world's fastest growing photosynthesizing organism, and if you give it a lot of sunlight and CO2, the algae's growth supersizes to amazing rates. This creates what we call biomass.
Biomass is anything that is a biological organism. Here we're talking about dried algae that can be used in animal feed, cosmetics, or pharmaceutical products.
What we're doing here is the algae is flowing through these tubes, getting access to sunlight, and then using photosynthesis, we're trying to harness that to sequester or mitigate carbon emissions from coal-fired power plants.
This process would enable us to design and build algae farms around coal plants that would eat CO2 emissions and create more products and fuel.
With all the coal we have in our state, it makes sense to use it responsibly.